So welcome back, class. This is the unit circle again. This is a blank one. I'm going to start off fresh. So last class, we talked about how this was, let's say this was 0 degrees, right? Actually, I want to do it in red. And this was, over here was 90 degrees. The quadrantal angles was 180 degrees to 70 degrees. And this is also 360 degrees, right? If you go full circle around, right? And if my radius is 1, which the unit circle is, that's why it's called the unit circle, right? Because my radius is 1. So from this point to this point, it's 1. This coordinate would be 1, 0. Yeah. 1, 0. This coordinate would be 0, 1, because all you're doing is just moving up 1. This coordinate would be -1, 0, because you're going to the left 1. And you're going down 1 here, where it's 0, -1, right? Let's get the radian measures. 0 degrees in radians, it's 0 radians. 90 degrees, or let's go 180. 180 equals what in radians? Pi. If 180 is pi, then half of it, which is 90, is pi over 2, right? Now look, this is pi over 2. This is 2 pi over 2, or pi. This is 3 pi over 2. And then this is 2 pi, right? Or 4 pi over 2, which is 2 pi. Okay? So I literally just went around 1 revolution in terms of pi over 2s, right? I know that 90 degrees is pi over 2. So another 90 degrees is 2 pi over 2. Another 90 degrees is 3 pi over 2. Another 90 degrees is 4 pi over 2, or 2 pi. Cool? We also talked about how this was 30 degrees, 45 degrees, and 60 degrees. And in radian measures, that would be pi over 6, pi over 4, and pi over 3, right? And we also said in this unit circle, our coordinate is going to always be cosine of whatever that angle is, theta, comma sine of whatever that is, theta. Right? So that is my coordinate. So I know that let's say, for example, the cosine of 90 degrees is going to be 0. Okay? That the sine of 180 degrees is also 0. Okay, just looking at the coordinate. Okay? And we went through this activity where let's actually do one. Just because this is somewhat new. Okay? So we said that that angle is 30 degrees, right? Yeah. So I plop this and I work on it. Let's work on it here. Okay, that's 30 degrees. And if I connect this point down, there's my reference triangle, correct? So in a 30, 60, 90, right? What's the ratio of the sides? Across the 30 is 1. Across the 60 is we're at 3. Across the 90 is 2, right? In a normal triangle, that's what it is. In this unit circle triangle, my radius is 1, correct? Well, which side is my radius? Let's see. It's going to be this 2 side, right? So remember we did this activity where I have to make this equal to 1. So I'm going to divide by 2, right? I'm going to divide by 2 here and divide by 2 here. Okay? So now this is 1. Now the units match up, and I can say, hey, look, this radius is now 1. So in order for me to get to this point, right, I'm going to go across to the right 3 pi over 2 and up 1/2. You guys see that? Yeah. Which is, so this coordinate is square root of 3 pi over 2 and 1/2. Okay. And then we made the conclusion where 3 pi over 2 is the cosine of 30 and 1/2 is the sine of 30. That's how we got this as our coordinate. All right. Does that make sense? Yeah. Questions? No? Should we do 45 as well? Because honestly, once we do this, the other quadrants, the other angles are going to be easy. So this is the radius, right? And that's 45 degrees. And here is my reference triangle. You guys see that? Yeah. So again, in a 45, 45, 90, what's my ratios? 1, 1 square root of 2. Same thing. If I want to plop this triangle onto, can't pick this up, onto my unit circle, where the radius is 1, this side here, the square root of 2 has to be 1. So in order for me to do that, I have to divide by square root of 2, right? Divide by square root of 2, divide by square root of 2. So square root of 2 over 2 equals 1. Or square root of 2 over square root of 2 equals 1. Yeah? So now I have a radius or hypotenuse of 1. Get back to your seat. Okay? So 1 over square root of 2. If I rationalize the denominator, it's square root of 2 over 2. This guy is also square root of 2 over 2. Make sense? Yeah? If I just rationalize the denominator. So now if I look at this, to get to this point, or the coordinate of this point here is going to be square root of 2 over 2, square root of 2 over 2. Right? Okay? So that's how we got that as my coordinate. Cool? Or the 60 degrees. Okay. There's my reference angle of 60. You can just sit right here. I want to make a reference triangle. Okay. So that is 30 because this is 60 and this is 90. 30, 60, 90 again, this is 1. Across the 60 is square root of 3. Across the 90 is 2. Same thing. I know that this is going to be my radius, right? So I'm going to divide it by 2 because my radius equals 1. Divide this by 2, divide this by 2. Okay? So if I look at it from the viewpoint of the unit circle, my coordinate is 1/2, comma 3 over 2, or square root of 3 over 2. Okay? So this is 1/2 square root of 3 over 2. And that's where we left off last class, right? Okay. I think that's where we stopped. Huh? This is the class where I stopped and we had 20 minutes left. I thought it was my third period. Oh, okay. So that was the lesson from before. Okay. I'm sorry, I got my periods mixed up. That's a weird statement. My class is mixed up. Yeah, I got my classes mixed up. I shouldn't say period. Okay. So what I want to do right now is look at this unit circle from the viewpoint of each special angle. Okay. Let's look at it from the viewpoint of this 30. Okay. I want to get slices of 30 degrees. Okay. And I'm going to keep going until I hit the whole circle. All right. So this is 30, right? 30 times 2 is 60. 60 times 2 is 90. 90, or I'm sorry. It would work better with radians. Okay. 1 pi over 6, 2 pi over 6, 3 pi over 6. You guys see how that's 2 pi over 6? Pi over 3 equals 2 pi over 6. Yeah. Actually, let's backtrack. So I feel confusion already. Okay. So looking at these, the angles in quadrant 2, if I look at this first one right here, what is this reference angle? 60, right? That's 60 degrees, correct? So if that's 60, if the reference angle, whatever your reference angle is, that relates to these angles here. Okay? Because this is just actually the reference angle, right? In the first quadrant, right? If I wanted to draw a reference angle of 45, I would draw this same angle, right? In my first quadrant. Okay? So since this angle has a reference angle of 60, it's going to be related to this guy here. Okay? This is actually 60 times 2 because that's 60, and another slice of 60 degrees is right here. So what's 60 times 2? 120. Pi over 3 is our 60 degrees in radians. So this would be 2 pi over 3. No, the radians. Yeah, I'm just looking at the 120 degrees for now. Okay. The coordinates are super simple. Okay. It's going to be the same reference triangle, correct? Yeah. So it's going to be that same triangle that we had here. Okay. But it's actually just flipped. Right? If you guys, I know I just flipped the paper. It's confusing. So it's going to be 1/2 and 3 pi over 2. So I'll get there. 1/2 and square root of 3 pi over 2. But since I went to the left, right, my x is negative. That make sense? Okay. So for the next one is a 45-degree angle. So pi over 4, 2 pi over 4, which is pi over 2, right? This is 145 This would be 2 45s. This would actually be 3 45s. So what's 3 times 45? 135. And it would actually be 3 pi over 2. Over 4. All right. So that's 3 pi over 4. So that is 3 pi over 4, right? And it's 135 degrees. Okay. So it's going to be this reference triangle, right? Just reflected. You guys remember that word from geometry or from integrated 2? Yeah. Across the y-axis, reflected across the y-axis. So this is square root of 2 over 2. This is square root of 2 over 2, right? So this would be square root of 2 over 2. This would be square root of 2 over 2. But again, since in my quadrant 2, my x is negative, my y is still positive, that will just be negative. Okay? So this angle here, we know that this angle is 30 degrees, right? If I draw that reference triangle, that's 30 degrees. Yeah. So what's 180 minus 30? 150. Does that make sense? From standard position, 180 minus 30. Yeah. Which is 150. Okay. And look at this. This is pi over 6. This is 2 pi over 6, which is pi over 3, right? 3 pi over 6, which if you simplify it down, it would be pi over 2. 3 pi over 6. 4 pi over 6, same thing, simplify it down. And then 5 pi over 6. This is 5 pi over 6. Okay? Carrying the momentum around, okay, around the circle, 5 pi over 6, 6 pi over 6. And then this guy is actually 7 pi over 6. This with just another extra 30 degrees is 8 pi over 6. 9 pi over 6, which is 3 pi over 2. 10 pi over 6. And then this would be 11 pi over 6. Okay? All right. Now the ones in pencil, these two guys, I did it in pencil because I can reduce it. So 8 pi over 6 would be 4 pi over 3. 10 pi over 6 would be 5 pi over 3. Okay? All right. And then let's do the pi over 4s. 3 pi over 4, 4 pi over 4, which is pi. 5 pi over 4. 6 pi over 4, which is 3 pi over 2. And then this would be 7 pi over 4. And then this would be 8 pi over 4, which is 2 pi. Does that make sense? I'm just adding 45 degrees or pi over 4s to what I already have, right? All right. So going back to the 150 and the coordinate. Does that make sense? Yeah. This guy would be my reference triangle, right? The 30 degrees here. But it would be like this. Correct? Yeah. So then this would be square root of 3 over 2 and 1/2. Notice that they have the exact same coordinates, right? But because this is in my second quadrant, this angle is in my second quadrant, my x is negative. That's the only difference. Whether my x or my y will be negative. Okay? So even quicker for quadrant 3 here. Since I already labeled it 7 pi over 6, I know that this reference angle is 30 degrees, right? 30 times 7 equals 210. You guys understand why it's 30 times 7? Yeah? Because 7 pi over 6 is 7 times pi over 6. Well, pi over 6 is 30. So 7 times 30 is 210. You guys kind of followed that logic? Yes? No? Maybe so? Hold on. I'm going to do this first. So since this is a reference angle of 30, I know my coordinates is going to be square root of 3 over 2, 1/2. Okay? I know that. But since I'm in my third quadrant here, my x is positive or negative? Negative. My y is negative. So they're both negatives. Okay? Go ahead. What is this guy? T. 225. Right? Because it's pi over 4. 5 pi over 4 has a reference angle of pi over 4 or 45 degrees. And it's 5 times 45, which is 225. Okay. So the coordinates here is going to be square root of 2 over 2. Square root of 2 over 2. But since both my x and my y are negatives, that's my coordinate. All right. And then 4 pi over 3, so 4 times 60 is 240. So that has a coordinate of 1/2 and 3 pi over 2. So I'm just going to write 1/2 square root of 3 over 2. Square root of 3 over 2, not 3 pi over 2. They're both negatives in my third quadrant, so they're both negative, right? Last one. 5 times pi over 3, which is 60. So 5 times 60 is 300. Let's do the angle measures first. Okay. 7 pi over 4, so 7 times pi over 4, or 7 times 45 is 315. 11 pi over 6, or 11 times pi over 6. Pi over 6 is 30, so 11 times 30, 330. And so I know it's pi over 3, so I know that reference angle, let me back up, is 60. So that's 1/2 square root of 3 over 2. But in my fourth quadrant, x is positive, y is negative, so that's negative. Right? Square root of 2 over 2, which is pi over 4. X is positive, y is negative, so that's negative. And then 30 degrees is square root of 3 over 2 and 1/2. X is positive, y is negative, so that's negative. See how we get a little faster? And that's your unit circle, class. Okay? So how are we going to use this in this class? You might be asking yourselves. We're going to have a bunch of these questions. What's the exact value of the cosine of 225. Okay. You can approach this one of two ways. Okay, the first way is be a robot and memorize that. Not my preferred way. Okay. Honestly, if you're gonna go that route, yeah, and you want to memorize, and that's how you learn, memorization. What I would do is memorize that first quadrant. Okay. Memorize the first quadrant and then see where the question, see what reference angle that is, right? Apply the first quadrant's reference angles, right? If it's 30, 45, or 60. Yeah. And then see if it's negative or positive wherever that quadrant is. See which one's positive or negative, and then find the cosine of 225. Does that make sense? Yeah. So if I use that for this question, cosine of 225, well, 225, this would be my train of thought. Well, 225 divided by 45 is 5, right? So this is actually 5 45s. Okay. So I know my coordinate is going to be a reference angle of 45, right? So that's square root of 2 over 2, square root of 2 over 2, because I memorized this guy, right? Okay. Oh, pi over 4. If it's ever in radians, this would just be 5 pi over 4. Okay, that's my coordinate. That's my radian measure. Okay. That's all the information, right, that I have here. Yeah. 225, if you think about it, it's in my third quadrant where x is negative and y is negative. So the coordinate is actually negative square root of 2 over 2 over negative square root of 2 over 2. Okay. And you know cosine is that x slot. So this is negative square root of 2 over 2. Okay. That's the train of thought. If you guys did that memorization. I would not recommend it, but if your brain works that way, go ahead. How I would approach this and how I recommend you guys approaching this, right? Is how we learned it in the first place. 225, if I draw that angle in standard position, that's 180 plus another 45. So it's actually the 45-degree angle here, right? This whole angle is 225. So drawing my reference angle, I know that this is 1, this is 1, this is square root of 2. I'm in my third quadrant where x is negative, y is also negative. My r is always positive. Yeah. Cosine is x over r. So it's negative 1 over square root of 2, which is negative square root of 2 over 2. Okay. That's how I would do it. If I needed it in radian measures, I know 180 is pi. I know 45 is pi over 4. So what's pi plus pi over 4? 5 pi over 4. Yeah. Okay. This to me shows me that you guys understand it, right? You guys know how to do it instead of doing that memorization. Because memorization will always fail. Yeah. Always. If I ask you like next year, hey, how would you do this? And you're good at it right now. Let's say you're masters at it right now, right? Yeah. Memorization, if you guys are masters at memorization or doing this way, next year, this time next year, you guys will remember how to do it if you guys practice it this way. If you guys go ahead and memorize it, You guys won't remember. Right? When was the last time you memorized for a test? You guys don't even remember when you guys memorized for a test. Yeah. And do you guys still remember that information from before? Little bit? Eh? Okay. But that is the lesson for today, class. The unit circle lesson.